6.2 Representations of functions. Definition for function rule. This is an equation that describes the relationship between inputs, which are the independent variable, and outputs, which are the dependent variable. So example 1, writing function rules. Letter A asks, write a function rule of the output is 5 less than the input. So we're going to break this up. The output. The output represents y. The word is represents equals. Then we have 5 less than the input. Well, 5 less than the input is going to be the input, which is x minus 5. So when we rewrite this together, y equals x minus 5. Letter B. Write a function rule for the output is the square of the input. The output, represented by the variable y, is indicates multiplication. I'm sorry, is indicates equals. The square of the input, that means that we are taking the input, which is x, and we're squaring it, which becomes x squared. So y equals x squared is the function rule. Example number 2, evaluating a function. Letter C, what is the value of y equals 2x plus 5 when x equals 3? Y equals 2x plus 5, x equals 3. Well, I'm going to take my x from my equation and replace it with my 3, because I know that 3 equals x. So this becomes y equals 2 times 3 plus 5. 2 times 3 is 6. I add 5, so that equals 11. That's saying that y equals 11. All right, we're going to try 2 different problems on your own, and then I want you to check this. Letter D, write a function rule for the output is 1/4 of the input. The output, that's represented with y, is translated to equals. Then we have 1/4 of the input. That is 1/4 times x. The word of indicates multiplication. So to match this up, of x. So this is y equals 1/4 times x, which is 1/4 x. Letter E is similar to letter C. We're going to find the value of y equals 7 minus 3x when x equals 5. Y equals 7 minus 3x. We're going to say that x equals 5. Well, I'm going to go in here and change and make this into adding a negative 3. Y equals 7 plus negative 3 times 5. This is 7 plus negative 15. I'm going to extend my work up here. Y equals 7 plus negative 15. 7 plus negative 15 is negative 8. So y equals negative 8. All right, letter F. We're going to graph the function y equals negative 2x plus 1 using the inputs of negative 1, 0, 1, and 2. So in my chart, I'm going to put negative 1, 0, 1, and 2. For the rule, that is my equation, y equals negative 2x plus 1. So for the first one, negative 1, y equals negative 2 times negative 1 plus 1. Negative 2 times negative 1 is 2. 2 plus 1 is 3. So my output is 3. That makes my ordered pair negative 1, 3. Then I'm going to solve for x equaling 0. So y equals negative 2 times 0 plus 1. Negative 2 times 0 is 0 plus 1. 0 plus 1 is 1. So I have 0 comma 1. Then I have y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2 plus 1. Negative 2 plus 1 simplifies down to negative 1. So I have 1, negative 1 as my next ordered pair. So before I use the rule to figure out my output, I can also check my ordered pairs to make sure that these are correct. So my x's go negative 1, 0, 1, then it should go 2 because they're all increasing by 1. My y's go from 3 to 1, 1 to negative 1. So they're decreasing by 2 every time. So that should be negative 3. So my ordered pair should be 2, negative 3, but I'm going to check it. Y equals negative 2 times 2 plus 1. Negative 2 times 2 is negative 4 plus 1. Negative 4 plus 1 is negative 3. And that is correct. 2, negative 3 is my ordered pair. So now I'm going to take these points and I'm going to graph them. I'm going to zoom in. So I'm going to plot negative 1, 3, 0, 1, 1, negative 1, and 2, negative 3. Then I'm going to take my line and I'm going to put it through all my points. So let's try this on your own. Graph the function y equals x plus 1. I'm going to use the same values as before, negative 1, 0, 1, and 2. My rule, y equals x plus 1. So y equals negative 1 plus 1, which equals 0. So my output is 0. I have negative 1, 0 is my ordered pair. Next, y equals y equals 0 plus 1, which equals 1. My output is 1. That gives me 0. 1 is my ordered pair. Next equation, y equals 1 plus 1. Well, 1 plus 1 equals 2, so my output is 2. My input is 1, so it's 1 comma 2. Next, I have x equals 2, so y equals 2 plus 1. That equals 3. So my ordered pair is 2 comma 3. So my x values increase by 1 every time, and so do my y values. So I'm going to plot negative 1, 0, 0, 1, 1, 2, and 2, 3. And then I'm going to draw a line going through my points. Oop. So let's try a real life application problem. The number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by the car. Write and graph a function that describes the relationship between G and P. Well, here's my P and there's my G. So the number of pounds P of carbon dioxide produced by a car is. So far I have P is 20 times the number of gallons G of gas. So that's 20 times G. If you notice, we're using P and G rather than X and Y. So for my input values, I'm going to start with 0, then go 1, 2, and 3. And it's because you can't have a negative amount of gas in your car. Once you hit 0, there's no more gas. It's just 0. So my rule, P equals 20G. So this becomes P equals 20 times 0. Well, 20 times 0 equals 0, so that's my output. 0, comma 0 is my ordered pair. Then we'll replace G with 1. P equals 20 times 1, which equals 20. So my second ordered pair is 1, comma 20. Now I'm going to replace G with 2. P equals 20 times 2, which is 40. That means my output is 40, so my ordered pair is 2, comma 40. Well, before I go and use my rule, for my last point, I can make a guess for my ordered pair. My x's are increasing by 1, and my y's are increasing by 20. So the next ordered pair should be 3, comma 60. So when I go in, I replace my G with 3. That becomes P equals 20 times 3, which is 60. So my ordered pair is 360. I agree. Perfect. All right, so now we need to go in and draw our graph, but we need to label our x and y axes. So our x-axis is our input, which is G. That is represented with gallons. Our output is pounds of carbon dioxide, which is abbreviated CO2. Bring in a little chemistry. So I started 0 for gallons. Now my input is going by 1. So it's 0 gallons, 1, 2, 3, 4, 5, 6, 7, and 8 gallons. Now, because my output, my y's are going by 20, I'm going to have my y-axis go by tenths. You could have it go by 20. That would be appropriate too. So 10, 20, 30, 40, 50, 60, 70. So 0, 0, 120, 240, 360. If you kept with the pattern, it would be 480. I'm going to take my line and I'm going to draw through.